Find the values of h for which the vectors are linearly dependent. So we can call this vector be v1, v2 and v3. So we write down the following linear combination: c1 v1 plus c2 v2 plus c3 v3 equals 0, and we want to make linearly dependent. Okay, that means the solution of this system should be non-trivial. So when we solve this system, c1, c2, c3, at least one of them should be non-zero. Okay, we know that 0 0 0 is always a solution because this is a homogeneous system right inside 0. If we multiply by 0, we always get 0. But that's not the point here. For linearly dependent, we want to find the constants so that one of them is non-zero. At least one of them is non-zero. So we have a system, and we can write down the corresponding augmented system for this vector equation using this, which happens to be first vector -2 7 1 8 5 -4 6 h -3, and from 0 all zeros. So we want to row reduce this. Okay, that means pivot in the very first, then we make 0 0 pivot 0. Okay, -2, look at in R3 we got 1, so we can swap R1 and R3. Okay, let's swap R1 and R3. So R3 becomes R1 1 -4 -3 0. R2 stays the same 7 5 h 0, and it is -2 8 6 0. Okay, row reduce means we want to make this 0, we want to make this 0, we want to make this 0. Okay, and this will be pivot 1, 5, that should be pivot, it might change. 6, that should be pivot location, but it might change. Okay, so looking at we can do two things at the same time. Let's make this 0. So for that we can R2, so to make 0, so R2 plus 7 plus -7 7 R1. Okay, that makes this 0, and we can make this 0 as well. So here 1 -4 -3 0. Now 7 times -7 is 0. 5 plus -7 times -4 28. 5 plus 28 33. Okay, here is h plus 21, this is 0. Now we can make this 0 as well. That means R3 plus -2, here is 2 times R1. Now if you look at closely, 1 -4 -3 0, the third row is just constant multiple of first row, because 1 times -2 is -2, -4 times -2 is 8, -3 times -2 is +6. So we don't have to even write anything, because we saw that these two columns are just constant multiple of each other. So we can pretty much say, oh, this is all 0. Okay, and we can just write 0 0 0 0. Now what can be said about this system here now? So this if we try to solve, this one is first column is for C1, this is for C2, and this is for C3, and there is no pivot in the last column. That means we have solution. Okay, there is no pivot in the last column, means we have solution. The system is consistent. And at the same time, there is no pivot in the third column as well. We got pivot here and here, but there is no pivot. That means this C3 is a free variable. Okay, this is free variable. Free variable means we always get non-trivial solution. In fact, we get infinitely many solutions. Okay, whenever there is a consistent system, we have two cases. One solution, same as unique solution, or infinitely many solutions. Here we got a free variable. Free variable means we get infinitely many solutions regardless the value of h. Regardless the value of h, we get infinitely many solutions. That means these three, the given vectors, okay, these three are linearly dependent for any value of h. Doesn't matter, h can be -21, that's fine, or any other values, because the third variable is always free. So we can conclude the given vectors are linearly dependent for any real h, for any value of h. So the answer is all real numbers. Okay, they are asking the values of h, that means all real numbers. Okay, final